Okay guys, so I'm not there today, so I wanted to make a video for your notes, and good thing is it's only one page. Also, the good thing is you already know a lot of these terms, you just may not know the proper names. So it's important for you to know these names because we are going to start getting into our proofs, and you have to have reasons for your proofs. And the reasons are going to be these properties, some of them at least. Okay, so to go through them, you guys already know this, the addition property of equality. Now make sure you know if it's of equality. So when you look at this, you're going to see the equal sign, right? That's what equality means. So all it's saying is, and I'm going to use a highlighter, that the addition property of equality says that if you add one thing to one side, you got to add it to the other, right? That's to keep the equation equal, right? Because if you only do to one, you got to do the other. Okay. The subtraction property of equality, same thing. If A equals B, then for them to stay equal, you're going to subtract C, but you also have to do the same thing on the other side. So you guys already know these things. It's just now you have to know the name. So the multiplication property of equality, if A equals B, then if you multiply one side by C, you got to multiply the other side by C. Same thing for division property of equality. If A equals B, then to make them remain equal, if you're going to divide one side by C, you're going to divide the other side by C. The distribution property you guys already know how to do. If you've got an A out here times a B and a C in parentheses, and distribution says when you multiply that, you got to multiply both the B and the C. Same thing if it were subtraction. It doesn't change the rule. You still need to multiply both the B and the C. Substitution property. Okay, so this one's going to get a little bit, we're going to use this one a lot, but you really need to understand it. So substitution says if I know that A is equal to D, and I know that A plus B is equal to C, then I can replace the A with the D because I already know they're equal. So then I could replace that equation and say D plus B equals C. So I'm making a direct swap, a direct substitution here. I'm taking D and replacing it with A only because I know that A is equal to D. This one seems kind of silly, but you're going to use this a lot. It's called the reflexive property, and that just means that if I know that A is equal to A, right? It's equal to itself. Anything is equal to itself. The symmetric property is a little bit different because now it's saying that if A equals to B, then B equals to A, meaning you can say it either direction. If you can say it either direction, then it's symmetric. The transitive property says if A is equal to B, and B is equal to C, then A is equal to C. So you're transferring that information through B, right? If you know that A is equal to one thing, and that one thing is equal to C, then the first two terms must be equal to each other. And we talked a little bit about that yesterday. That's kind of like syllogism, if you remember. Okay. So now, since I said we're going to get into proofs, what we're going to do now is we're going to solve basic algebraic equations, but I'm going to show you now that you have to justify every time you make a step. Okay, so for those of you who have been going through school and showing all your steps, this is going to be somewhat easy. Alright, so what I might do first on this equation, and of course what you do first and what I do first really is not that big a deal if it's different as long as we're following the PEMDAS rules, correct? So I'm going to go ahead and add 7 to both sides, which would give me 3x is equal to 5x, minus 12? Okay, but here's where the work comes in. I have to justify that step. And what I did is I added 7 to both sides, so what I used was the addition property of equality. And I'm just going to kind of make it short. Addition property of equality. Okay, so now I'm going to go ahead and I'll subtract 5x. So I've got negative 2x is equal to negative 12. And again, how can I do that? I can do that because of the subtraction property of equality. Okay? And then once I get to this step, I'm going to end up dividing both by negative 2, which will give me x is equal to 6. But again, how am I able to do that? I'm able to do that by using the division property. Property of equality. Okay? So I know you guys like to shorten your words, and it's okay as long as I can read it. So I'm using equality, and you'll see in the next one I'm actually going to shorten that up even more. Okay, so when I look at this next one, using algebraic rules, I could divide by 5 or negative. I could divide by negative 5 or 2 if it would make sense and make it more efficient, but it's not. So my first step in this problem is going to distribute. So I'm going to distribute the negative 5 over here and get negative 10u minus 50 is equal to, and I'm going to distribute as well on the other side, 2u minus 14. And I'm going to say the reason why I can do that is based on the distribution property. Distributive property. Okay. Once I have that, then I'm going to go ahead and go through my steps, and I'm going to add my 10u, get negative 50 equals 12u minus 14. And why? How can I do that? That was the addition property. And again, I'm going to shorten it up some. Addition property of equality. This of equality is important because we're going to be getting into congruence too. Okay, and then I'm going to add 14. Oh boy, what is that? That's negative 36 is going to be equal to 12u. And again, what did I do? I added, so the addition property of equality, and then I'm going to divide by 12. So I'll get negative 3 is equal to u. And what did I do? I did the division property. Oops, y'all can't see this. Division property of equality. And then in algebra, we like to have that u come first. So what we could say is u is equal to negative 3. So what did we do? We ended up switching like this. So we used the symmetric property on this one. Okay, so that's what you're going to be doing in your homework too. So you're going to be doing some algebraic problems, and for each step you need to show me your work, and then you have to justify how you know you can do that. Alright, so now for the next part. Now we're getting into a little more of a proof. And I'm still going to kind of write it like we did up there. I'm not really going to present the proof format yet, but I am going to show you how to work it. So here's a picture. For every proof you're going to want a picture. They're going to be giving you a given statement, and they're going to give you what you want to prove. Okay? So it says you bounce a pool ball off the wall of a pool table is shown. Determine whether the measure of RTP is equal to STQ. So you're trying to figure out, is this angle equal to this angle? Okay, that's what you're trying to prove. You're given that RTQ is equal to the measure of STP. Okay, so this whole angle is congruent to this whole angle. So when we start a proof, we always start with the given. So I'm going to go ahead and start with that. So I'm going to say the measure of angle RTQ is equal to the measure of angle STP. Okay, now knowing that, And my reason for saying that is because it was given. Always have to have a reason. Okay, the next thing I can do is I can say, well, what is RTQ made out of? RTQ is made out of RTP and PTQ. And how do I know that? What rule is that? Well, that's my addition postulate, right? Segment addition postulate. So I'm going to say I can replace this. Actually, I'm not going to do that yet. What I am going to say is I'm going to say the measure of angle RTQ is really made up of the measurement of angle RTP plus the measurement of angle PTQ. Now, how do I know that? That's my segment addition postulate, which we have already learned about, right? Okay, if I can say that about this one, then I can also say that about the other angle. So I'm going to say the measure of angle STP is equal to the measure of angle, STQ plus the measure of, and I could say QTP, but I'm going to go ahead and say PTQ because either way it's the same thing. So I'm going to say PTQ. And again, that is my segment addition postulate. Okay, I can say this because of this. Now, because we knew these were equal, these two were equal, then what I can do is I can make these two equations equal. So I can say the measure of angle RTP plus the measure of angle PTQ is equal to the measure of angle STQ plus the measure of angle PTQ. Now, how did I do that? So if you're looking at the rules up here, what I did was I said, well, if I know that, where is it? If I know that, substitution, if I know that A equals D and A plus B equals C, then D plus B equals C. So what I'm really doing is I'm doing substitution. So I use this by saying substitution property. Right? Because I already know these are equal. I know this is equal to that, and this is equal to that. So these two things must be equal to each other. Okay? By substitution. So now I've done, so I'm looking for this proof statement, but look at the equations. This and this are the same thing, right? So I can actually subtract those out. So if I take those out, I'm going to be left with the measure of angle RTP is equal to the measure of angle STQ. And how did I do that? I did that by the subtraction property of equality. Now notice, what you don't see is you don't see me actually doing the subtraction. So you don't actually have to show the subtraction step, but you do need to tell me how you got to the next line. So that's why I'm using that subtraction property. Okay, so basically I've proved the statement I was looking for. I've proved that RTP is equal to the measure of STQ. Okay, so don't get too upset about all of this, okay? You're going to be focusing on this kind of practice in your homework, okay? And you will be learning a little bit more about these properties up here. So other than that, you're free to get started on your homework and have a good weekend. Thanks.